Chapter 6, covering Lewis dot structure, shape, bond angle, and polarity, and this is introductory chemistry at Monroe Area College. So my first example, I have carbon dioxide, also known as CO2. The number of valence electrons from the periodic table is going to be 16. And so you're just going to trust me on this. If you start off with single bonds on both sides, then you're not going to get 16. So I'm just going to give you guys a hint and put double bonds on both sides. And so carbon dioxide, it's going to need 16 valence electrons total, but currently it has 2, 4, 6, 8 valence electrons. So we need to draw 8 more valence electrons, but since carbon is satisfied because it has 1, 2, 3, and 4, it already has sort of like all of its surroundings sorted out, so it's going to not need any more valence electrons to be added onto it, and so what's left is we need to use the oxygens. So we need to draw on 8 more valence electrons total, so 1, 2, so 2, 4, 6, 8, 10, 12, 14, 16. So we already have 16 valence electrons after the drawing of the Lewis dot structure. And so now we're going to move on over to the EGA, shape, bond angle, and polarity. So since carbon only has 2 of its sides filled out, on its left side and its right side doesn't have the top or the bottom filled out, the EGA is just going to be over here. It's going to be 2. And so then the EGA is going to be linear because it only has 2 electron groups. So the shape is just going to have to be linear as well because that's the only thing that's left over here for the linear EGA. So the shape has to also be linear as well. The bond angle over here is 180 degrees. And its polarity, since it is going to be a linear shape, it's going to be nonpolar. Next, we have carbon tetrachloride. And so from the periodic table, it's going to have 32 valence electrons. And so the only way you can set it up is carbon in the middle. And so since it's already satisfied all around, all we got to do is just fill in the rest of the electrons, and so we have 2, 4, 6, 8. We already have 8 valence electrons, so we are going to need 24 more valence electrons. And so we can just pretty much fill out the rest. Oops, that's one. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we have 32 valence electrons total. And so the EGA is just going to be tetrahedral because there are 4 electron groups total. And so the EGA is going to be tetrahedral. And so the shape is going to also be tetrahedral because there are 4 bonding groups and no lone pairs around the carbon, as stated over here. The bond angle is going to be 109.5 degrees because that's also what our chart says. And so the polarity is actually going to be nonpolar because since it is symmetrical, since it is tetrahedral, it's going to be nonpolar. So the next one, I have water, also known as H2O. It's going to need 8 valence electrons total from the periodic table. And so the only way you can set it up is O being in the middle. And then since hydrogen can only take 2 electrons at a time, which is indicated by 1 line, it's the only way that we can draw the Lewis dot structure. We can't add in a triple bond or a double bond because it would be too much for the hydrogens. And so since this is 2 and 4, what's left is 6. Oops. What's left is just going to be 6 and and 8. So we have 2, 4, 6, 8. We have 8 valence electrons total. The EGA, simply because it has 4 electron groups around it, 1, 2, 3, and 4 around the O anyhow. And so then the shape is going to be bent because there are 2 lone pairs, and then there are also 2 bonding groups. So 2 lone pairs and then 2 bonding groups. So the shape is going to be bent. Right down here, it tells us that the angle is going to be 105 degrees, and the polarity, since it is a bent shape, it is not symmetrical in a sense, well, theoretically, then it's just going to be a polar molecule. And it's just easier to remember that water is a polar molecule because that's what we're going to have to be dealing with throughout the rest of Intro to Chem anyhow. Next, I have nitrite, which is NO2 with a superscript of -1. And so normally NO2 would tell us that there are going to be 17 valence electrons from the periodic table, but since it is a -1 charge, it's gaining 1 more electron, it's going to have 18 valence electrons total. And so just to save you guys some time, you're going to have a double bond and a single bond between one O and then the other O. And so now we just have to fill in the rest. We have 2, 4, and 6. We have 6 valence electrons in this picture right now. So 18 minus 6 is going to be 12. So we need to put 12 more valence electrons onto this picture. And so we know that since oxygen has 2 and 4 already, it needs 6 and 8 to be satisfied. So this side of the diagram is already done. And so we know that nitrogen, it has 2, 4, and 6. It has 6 electrons currently, so it needs 2 more to reach 8 to follow the octet rule. And now we have this last oxygen, and so since it only has 2 valence electrons attached to it currently, it's going to need 4, 6, and 8 electrons total. However, because there is a -1 charge up here on the periodic table, what we're going to have to do is just put a bracket around it and put a -1 because it has a -1 charge. It's an ion, and so that's what you're going to need to do for all the ions. And so next, the EGA is going to be, it will be trigonoplanar because it has 3 electron groups, 1, 2, and 3. The shape is going to be bent because it has 2 bonding groups over here and over here, and then has 1 lone pair. So the bond angle then is going to be 118 degrees. And the polarity, since it is a bent shape like water, it's going to be a polar molecule. And so that's all I have for today. Thank you for watching.